We want to find the limit, if it exists. To determine the limit of a function of two variables, if we cannot perform direct substitution to determine the limit, we need to determine the limit from several paths approaching our point, or in this case, the origin. Some of the most common paths that would approach the origin are pictured here on the right, along the x-axis or y equals 0, along the y-axis or x equals 0, as well as the lines y equals x and y equals negative x, as well as the parabolas y equals x squared and y equals negative x squared. Notice all these paths approach the origin, and therefore we can use them to determine if this limit exists and hopefully determine what the limit is. So we already noticed we cannot perform direct substitution because if we did, we'd have the indeterminate form of 0 divided by 0. It's often helpful to analyze the graph of the surface if you do have three-dimensional graphing software available. I provided the graph of our function here. So looking at our surface, notice how this would be the point on the surface corresponding to the point 0, 0. And it does appear if we approach this point from any path, we would obtain the same function value. But again, we do want to verify that by considering several paths. Probably the two most common paths to use that approach the origin would be the x-axis or y equals 0, as well as the y-axis or x equals 0. Let's consider these two paths first. So for the path along the x-axis or y equals 0, we'll substitute 0 for y into our limit. So we'd have the limit of x comma 0 approaches 0 comma 0. And now we'll substitute 0 for y in our function. So we'd have x squared times 0 divided by x squared plus 5 times 0 squared. Simplifying, we have the limit of x comma 0 approaches 0 comma 0 of, we'd have 0 in the numerator and x squared in the denominator. Notice as x approaches 0, this would be equal to 0, and therefore this limit is 0. Even though when x equals 0, we'd have 0 divided by 0, we only care about the value this is approaching as x approaches 0. Now this does not tell us this limit is equal to 0. This just tells us along this path the limit would be 0. Let's also consider the path x equals 0, which would be along the y-axis. So we'd have the limit of 0 comma y approaches 0 comma 0. Substituting 0 for x, notice how we'd have 0 in the numerator, and our denominator would be just 5y squared. And once again, notice how this is equal to 0 for all values of y except y equals 0, and therefore this limit is also 0. So now we've shown along these two paths the limit would be 0, which again doesn't mean this limit here is equal to 0. Let's consider a couple more paths. Let's now approach the point 0 comma 0, or the origin, along the line y equals x, as well as the line y equals negative x. Again, if we determine one path that gives us a limit that's not equal to 0, we know this limit does not exist. So now for the path y equals x, we'd have the limit of, we'll substitute x for y, so we'd have x comma x approaches 0 comma 0. Now if we substitute x for y, notice the numerator would be x squared times x, or x cubed. The denominator would be x squared plus 5x squared, which would be 6x squared. Now this does simplify. We would have the limit of x comma x approaches 0 comma 0 of, this would simplify to x divided by 6. But notice that as x approaches 0, this limit is equal to 0. So now we've shown from three different paths as we approach 0 comma 0, the limit is still 0. So it is looking pretty good that this limit will exist. Let's go ahead and try the path y equals negative x as well. So we'll substitute negative x for y, so we have the limit as x comma negative x approaches 0, 0 of, again we're substituting negative x for y, so in the numerator we'd have x squared times negative x divided by x squared plus 5 times negative x squared. So simplifying, we'd have negative x cubed divided by, this would be 6x squared. Again, this simplifies. We have the limit of x comma negative x approaches 0, 0 of, this would simplify to negative x divided by 6, which once again does give us a limit of 0. Now I've considered 4 paths approaching the point 0, 0, and notice from each path the limit was equal to 0. So at this point I think it's safe to conclude, based upon our paths and by analyzing our surface shown here, that the original limit is equal to 0. However, more formally, to verify this limit is equal to 0, we would have to apply the formal definition of a limit of a function of two variables. I hope you found this helpful.